The spinal cord is housed inside the spinal column, the vertebral column. Let's take a look at it. Your vertebral column is made up of vertebra, and these white discs intervertebral discs. Now, the spinal column is broken up into segments. The top five vertebra are the cervical vertebra. The middle, oops, that was silly. The top seven are the cervical. The mid 12 are the thoracic. And the bottom five are the lumbar vertebra. This is your sacrum. Used to be vertebra, now they're fused in us. And this is your tailbone or your coccyx. And your pelvis is here. As you can see, the sacrum fits like a capstone right in there, wedged in. Okay, let's talk about how this structure came to be. So, for eons, the spine had to support bipedal animals. So, this structure is most used to these kinds of forces. But what did our species do? We stood upright. Now, the forces we exert are in this direction, they're in twisting, they're bending. This structure is doomed to fail. That's why back pain is essentially universal. Eventually, you might be lucky, one of the very few, but you're very likely to have a problem with pain in the back. Now, what's happening? These discs, these intervertebral discs, simply fail. Now, let's look at some discs. Here's a perfectly healthy disc. So, this is a sagittal MRI. The person's belly is here. This is their back. This is their rear. Their head's up above the screen. This is a healthy disc. Perfect. You see, in this kind of MR, water shows up as high intensity. So, what this is showing is that these discs are juicy, plump, and moist. Now, look at these two. These are beginning actually into the degenerative process. This is called desiccation or drying out. Shortly after drying out, the disc begins to collapse. What you're seeing here is a herniation, where some of that juicy disc material has squirted out into the spinal canal. Here's a really bad one. So this is where the disc is supposed to end. Look at all this disc material that has squirted out into the spinal canal. Now you see these dark strings, spaghetti strings? These are your spinal roots. They're being compressed. This is going to hurt tremendously. Here are a couple other cases. So this patient's problem, if we're looking, everything's okay, but wait, there's something weird here. This is sacrum, L5, 4, 3, 2, 1. So at L2, at the L2-3 disc, there seems to be have been a herniation that has now squirted, is going superiorly. If we look at a cross section, so a slice right through here, that's what this is. This is the disc. This is the spinal cord. And this is the herniated portion. What it's doing is it's putting pressure on the spinal cord and the nerve roots from more superior parts of the spinal cord. They all come down, right? They're all coming down. Here's a really severe one. Look at this herniation here. We take a slice. This is a sacrum. This is L5. L5 to sacrum disc is often the first to go. You're seeing it in, actually, except for this case, you're seeing it in these other three cases. So here's the disc. It's supposed to end roughly there. But this is a herniation. Now look, all this space where the spinal cord, actually at this point there's no spinal cord, the spinal roots are traversing. They're all moved over. You see the roots are all bunched up right here, here. This is extremely painful. Now, aside from pain, you can begin to cause permanent damage to these nervous structures. And permanent is permanent. I twisted around this image. So this is the dorsal aspect. This is the dorsal aspect. What's dorsal for humans? This is our back. This is our belly. Okay. The more dorsal aspect of the spinal cord is processing touch. So the dorsal roots are incoming and right up the spinal cord up to the brain. The ventral roots, these red tracts, are motor commands coming down and going out the ventral roots. Did I just misspeak? Dorsal, sensory, ventral, motor. Motor coming down from the brain, and then the dorsal going up. This is a dermatome map. What it's showing you are parts of the body serviced by the nerve roots coming out from each of these locations. So, if you have, this is pretty darn common, a pain in your hand, and it's focused on your pinky finger and your ring finger, you might think there's something wrong with your hand or your wrist or your elbow. But if you exclude all those, and your doctor, any smart doctor, has to start investigating your spine. Because pinching a nerve here will cause pain in the hand. You see the dermatome? Let's pick another spot. Leg pain. A lot of times people have leg pain. They don't quite understand what the heck is going on. Why does my leg hurt so much? Well, let's take a look. A very common area is this lateral region here, L4, L5. Uh-huh. So we look, and the problem is liable to be emanating from these areas here. And often a little bit from L3 and then from S1, so on. Now this looks a little odd, right? But remember, we're the ones who are strange. Nature developed the animal mostly on a quadruped body. So how about this view? Does this make more sense? When you imagine a person in all fours, you see that the dermatomes are actually very logically organized. Looks odd, upright, but that's because we're strange. When you put a man on all four, you see exactly what's going on and why the cervical vertebra service the arms, why the lumbar vertebra service the legs, and the lower back.